Hi Bobcats, this is Miss Lee, and today's video lesson is on comparing ratios with tables. Please make sure as you watch the video that you're taking good notes. Okay, a ratio table represents a relationship between two or more quantities by creating a list of equivalent ratios that can be used to make multiplicative comparisons and solve prediction comparison problems. Okay, so a ratio table is just a table that lists the ratios, and they can list multiple equivalent or equal forms of the ratio. And we use the tables to make comparisons and to solve prediction problems. So take a look at our first table here. This is a table about cooking rice. So the two things that we are comparing, or the two parts of our ratio, would be the number of cups of rice and the number of cups of water. So it tells us the ratio is a 1:3, meaning we use 1 cup of rice for every 3 cups of water. And there's different ways you can make your table. And this table, they're listing the multiples. So it goes from 1 cup of rice to 2 cups of rice, so they double it. Then they triple it to get 3 cups of rice. Okay, then the next multiple would be 4, and then they go and they extend it, they jump up to 7. It goes from 4 to 7. So when you're listing your equivalent ratios, you have to do the same thing for the second part of your ratio. So we know our ratio begins with 1:3, 1 cup of rice for 3 cups of water. Then we double that amount. So if we're going to double the amount of rice and do 1 times 2 to get 2 cups of rice, then we have to double the amount of water as well. And 3 times 2 would give us the 6 cups of waters. This 2 to 6 is equivalent to this 1 to 3, because if you were to simplify this 2 to 6, it would equal the 1 to 3 ratio. Then let me change my color here to show the next one. So now we go from 1 to 3. So we're tripling. Or if you're listing the multiples, 1, 2, 3. So then if you triple the number of water, it would be 3 times 3, or 9 cups of water. And then you can use this table to solve questions. Okay, make predictions. What if I want to know, excuse me, if I want to know if I use 6 cups of rice, then how many cups of water would I need to have? Well, you can continue your multiples, 1, 2, 3, 4, 5, 6. Or you could say, oh, well, I just need to multiply the 1 times 6 to get the 6. So then I would need to do the same thing to the 3. And I would need to multiply 3 times 6, and that would give me 18 cups of water. That's what a ratio table does. And it seems kind of confusing, but we're going to work some examples. Okay, Joshua is creating a Lego log cabin, which requires his structure to have 7 small bricks for every 2 large bricks. We want to complete the table. Okay, so we know 7 to 2, 7 small to 2 large. And it's really important if you're making your own ratio table that you have the labels here. You've got to have the labels so you know what the 7 represents, what the 2 represents. And you could make your table and list the multiples of 7. It would be 7, and then 14, 21, 28, 35, and so on. Or you can look at this and say, okay, I want to go from 7 to 21. How am I going to get there? And remember, these are multiplicative comparisons. So that means you need to multiply 7 by some number to equal 21. Just like a scale factor, right? Multiply the 7 times 3, and that will give us the 21. Well, if we want to know how many large bricks are needed, then you have to do the same thing with the 2. You have to use that same scale factor and multiply it by 3, and 2 times 3 is 6. So if you have 21 small bricks, you would need to have 6 large bricks. You could have also listed the multiples. Multiples of 2, 2. 4, what comes next? 6. So let's go on to the next one. This time we're missing how many small bricks we need when there are 10 large bricks. So you could continue your multiples 2, 4, 6, 8, 10, and then continue the multiples for 7, 7, 14, 21, 28. What would come next? 35. Or you could think more about the scale factor. What do we need to multiply 2 by to make 10? And that would be times 5. So use the same scale factor for the 7, and 7 times 5 gives you that 35. And our last one, we have 63 small bricks. How many large bricks do we know, or do we need? So you could continue your multiples. Sometimes that could be a lot of multiples, right? Or you could just say, okay, what's my multiplicative comparison? What do I need to multiply 7 by to make 63? And that would be 9. So use the same scale factor on the 2. Multiply the 2 times 9 and you get 18. So if you have 63 small bricks, you need 18 large bricks. So I have a question for you. What would you do if you wanted to know the total number of bricks used if 70 small bricks were used? So pause the video, read the question to yourself again, and see if you can find the answer. Okay, so it's asking us how many total bricks would you use if 70 small bricks were used? So we know we're going to have 70 small bricks, but we want to know the total number of bricks, not the total small, not the total large, but altogether the total bricks. So that means we want to know the small plus the large bricks to get the total. So if I have my ratio of 7 small to 2 large, that would be a total of 9 bricks used. If I had my 35 small to 10 large, that would be a total of 45. So what would this total be if we had 70 small bricks? Well, again, to find the total, we need to add the small plus the large. So we have to figure out how many large bricks do we need. Well, I'm going to go over here, find my scale factor. I know that 7 times 10 will give me 70, so I'm going to use the same scale factor with the 2. And 2 times 10 is 20. Now I know the number of small, I know the number of large bricks, I add them together. 70 plus 20 is going to be 90. So there would be a total of 90 bricks used. Okay, the ratio of boys to girls in the school musical is 5 to 8. Which ratio could represent the number of girls to boys in the school musical? So we're going to use this ratio table to help us find the correct amount. Okay, our ratio is talking about boys to girls, so let's write it. Labels first, boys to girls. And it tells us that that is 5 to 8. Going in the same order, the 5 represents the number of boys and the 8 represents the number of girls. Now this one can be a little tricky because it wants us to give us the number of girls to boys. So it's switching the order on us, isn't it? But that's okay, we can do this. Let's go ahead and use our ratio table. Let's list multiples. Okay, if we're going to go 5, what's the next multiple for 5? 10. The next multiple would be 15, then 20, then 25, and so on. Now, do the same thing for the 8. 8, list your multiples, 16. Then 3 8s would be 24, 32, 40, and so on. Okay, now let's see if we have enough in our table to help us answer this. We want the ratio of girls to boys, which would be equivalent or equal to this. Well, I have 16. I'm going to put a G for girls to boys. As 16 girls, here's a 16 to 10 boys. Is this equivalent? Yes, this one is equivalent. What about the 15 to 18? 15 girls to 18 boys? Well, if I look on my girls, there is no 15. There's a 15 up here, but on the boys, but not for the girls. So that cannot be our answer. 20 girls to 32 boys. Well, if I come down here on my girls, there is no 20. So that one doesn't work. And what about 25 girls to 28 boys? Again, when I look down on my girls, there is no multiple of 25. So the correct answer for this one was A. Okay, last example. A pet store sells cats and dogs. The ratio of cats to dogs is 6 to 8. If there are 72 dogs, what is the total number of pets in the store? Okay, so the ratio that they're giving us, what we're comparing is cats to dogs. Remember, we always want to circle that word too. And we know that ratio is 6 to 8. Our table's been started for us. Cats, dogs, 6 to 8. And then it's got a third row. It's got the total. Remember when we talked about ratios, we said it could be a part-to-part comparison, which would be like cats to dogs. It could be a part-to-whole comparison, which would be like cats to total or dogs to total. Or it could be a whole-to-part comparison, like total to cats or total to dogs. Okay, so that's why, because we are talking about total number of pets, that's why we have that third column to represent the total. So we're wanting to find the total when there are 72 dogs. So ratio table, multiplicative comparisons. You could list your multiples. 8, what comes after 8? 16, 24, 32, 40, 48. What comes next? 56, 64, and then 72. Okay. So you could do the same thing for the total. But first we have to find the total. Well, if there are 6 cats and 8 dogs, add them together and you get your total, which is going to be 14. Then you can list your multiples of 14, 14, 28, and so on. And honestly, I don't know my multiples of 14. So I'm going to try to find something a little bit easier. I know I need to turn this 8 into 72. How can we do that? We can multiply by 9. Multiplicative comparison. What can you multiply 8 by to make 72? 9. Then you would do the same thing with the 14. Use that same scale factor and multiply 14 times 9, and you get 126. So that's one way you could use a scale factor. Okay, the other way, let me change my color here. I'm going to keep with the pink theme back here, is we listed the multiples for dogs. We can list the multiples for the cats. 6, 12, 18, 24, 30, 36, 42, 48, 54. And we can stop. Then all we have to do is add cats plus dogs, 54 plus 72 equals the 126. So with the ratio table, the one thing that's fun about this is that there's not one way you have to use the ratio table. There are different ways you could use the ratio table. Okay, you could have also done this. I'm going to confuse you even more. Change it to blue here. When you're listing your multiples, you could have come up with 2 numbers, 2 of the dogs that you could add together, 2 amounts to make 72. What 2 numbers do you think you could add together to make the 72? You could have added the 64 plus the 8 to make 72. Then you could have added the 6 for cats and the 48 for cats, which would have given you the 54 for the total number of cats. Then added the 54 to the 72 and gotten 126. So again, there's a lot of different ways you can use the ratio tables, and you just have to play around with them. There is not one correct way to use it. Okay, Bobcats, good job.